So good afternoon, everyone. We now have Sweigart, who will be talking on, yes, it's time to learn regular expressions.
Hello, hi, I'm Sweigart. I'm probably best known for writing Python books, including one called Automate the Boring Stuff with Python, which is released under a Creative Commons license, so you can read this online for free. You can check out the book, and also my slides from bit.ly/yesregex if you want to follow along with the slide deck. I really encourage you to release your own content under an open license like Creative Commons. One of the benefits that I have is that I can take a look at my web traffic, and I noticed that the regular expression chapter in this book has a lot of traffic, so I thought, hey, this would be a good idea for a talk. So regular expressions are kind of this intimidating topic. A lot of software developers pretty much put off learning it for most of their careers. It seems really cryptic. There's a bunch of weird punctuation marks that have special meaning. It can be kind of hard to learn. In fact, just 20 minutes before this talk, I overheard somebody in the hallway say this quote, and so I had to update my slides with that. But in general, their regular expressions are really powerful if you have to do text pattern matching. And I really encourage you to learn them. And so, yes, it's time for me to start this presentation, which is entitled, Yes, It's Time to Learn Regular Expressions. So the first thing that you'll learn is that they're also called regex for short. So here's two numbers. Actually, it's one number, and one of these numbers is a phone number, and the other is the population of Asia. So which one is which? Well, if you're like me, you've memorized every single American phone number that exists, and you can tell that that top number is one of them. No, that's not how you actually do that at all. You know it's a phone number because you know a phone number when you see it, and you know it when you see it because you know there's a specific pattern that that all American phone numbers follow. It's a few digits for the area code with dashes in the middle of it. So that's what regular expressions do. You can specify a pattern of text that you're looking for, even if you don't know the exact numbers or the exact text that you're looking for. And it's really easy. Python makes this really simple. It's just about 3 lines of code. The first is to import the regular expression module, which is import RE. Then you want to call the compile function and pass it your regular expression pattern that you're looking for. Then you're going to call the search method on the regular expression object that returns. And you pass it the haystack string. I call it the haystack string. If you're looking for one string inside of another, I say you're looking for the needle string inside the haystack string. And that's going to return a match object, and you call the group method on that. And that will print out the exact text that you're looking for. So did I say 3 lines? I meant 4 lines. But it's still basically just 3 lines of text. Compile, search, and group. And also, if you're busy scrambling to write all of this down, remember, you can download these slides at bit.ly/yesregex. So just calm down, don't stop taking notes, and listen to my soothing voice. Let's focus in on each one of these parts. So starting with compile and this regular expression string of the pattern that you're sending to compile. This is the main complicated part of Python's regular expressions, figuring out the syntax for this. So let's go back to that phone number example. What exactly is a phone number? How do you know a phone number when you see it? Well, it starts off with a digit character, which is one of the 10 numerals 0 through 9, followed by another digit character, and another digit character, and then a dash, and so on. So we need to translate this into a regular expression string in the regular expression syntax. And that's what we're going to pass to compile. Remember, there's compile, search, and group. So we're going to use /d, which is the regular expression syntax for a digit. You want to really pass this as a raw string, because otherwise, if you don't have a raw string, you're going to have to escape that slash, and you're going to have all of these slashes in your regular expression string. So I tend to like to send raw strings always to the compile function. So this /d will match a digit character, and our phone numbers are going to have 3 of these for the area code, followed by a dash, and so on. This is the regular expression string to match a phone number. After that, we get the regular expression object, and we can call search on that and pass it our haystack string. This is the string that we're searching for that pattern we're looking for. And it'll return a match object. And it'll return a match object if it finds the pattern. Otherwise, it'll return none. So we have to check if the match object is none or not. And when we call group on that match object, remember, compile, search, group, that's going to print out the actual text that matches the regular expression pattern that we were looking for, just like that. Now, this seems, I know I said that, oh, it's a lot easier than you think. This is still kind of complicated, remembering compile, search, group. If you're just calling the find string method, that's a lot more straightforward. It's just one line of code. But imagine if you didn't have regular expressions to do this find phone number example. You would have to write Python code that looks like this, which isn't that hard to follow, but it's a lot of it, and it's really gnarly. And phone numbers are actually pretty simple patterns. Once you get into really much more complicated regular expressions, the Python code that you would have to write to do the same thing as a small regular expression would just explode across pages and pages of text, and we don't want that. So let's examine that /d thing that I was talking about earlier, that matches a digit. This is something called a character class. It represents a range of characters or a class of characters that you're looking for. And /d is the one saying, I'm looking for a digit, one of the numbers. There's a few other character classes. There's /w for word characters. This is letters and numbers, and I believe also the underscore character. There's /s for space characters like space and tab and new line. And there's also the capitalized versions of these for everything that's not a digit or not a word or not a space character. Character classes are how you specify what exactly you're looking for. So whenever you're searching through a string, try not to think of the actual semantic meaning of whatever text you're looking for. Just consider that string to be a sequence of symbols that you're looking for. And these character classes match a certain group of symbols. You can also create your own character classes by putting a bunch of characters inside the square brackets. So if we wanted to, say, create a character class that matched all the vowels in the English language, we'd just type A-E-I-O-U in lowercase and uppercase inside the square brackets. And now we have a character class matching vowel characters. We can also do the same thing as the uppercase version of those previous character classes by just adding a caret character to the very front of this character class. And now this is matching everything that's not a vowel character. So that's going to be consonants. It'll also be something like punctuation marks or numbers. That's something that you have to keep in mind. It's everything that is literally not those 10 characters. And we can also have ranges of characters. If you want to match, say, all 26 letters or all 10 numbers or both of those things, you can just use a dash character to have, say, 0-9, and that's going to be all 10 characters. And this character class basically does the same thing as the /w character class. It's matching all the numbers and letters. So in these examples, we had the caret character at the very beginning, or those dash characters. We're not literally looking for those characters. Punctuation marks in regular expression syntax tends to have very specific meaning. So if we're actually looking for any of these punctuation mark characters, just be sure to escape them with a backslash in front of them. So if, say, we wanted to create a character class that matches open and closing parentheses, we can just add a slash character in front of those parentheses, and now we have a character class that matches a set of parentheses, either the opening or closing characters. So character classes, as I said, this is what you're looking for inside of your regular expression. It's how you tell Python, I'm looking for these characters. You can also specify a quantity of these characters. We kind of did this with the phone number example just by repeating the /ds over and over again. But there's a shortcut for this. You can use curly braces and a number in between the curly braces to say, hey, I'm looking for 3 of these digit characters, followed by a dash, and so on for the rest of the phone number example. This matches the exact same thing as the previous regular expression, but it's a bit more compact. And here's the pattern that we're following right here. We have /d, that's the character class, that's what we're looking for coming first, and then after that, we have the quantity that we're looking for. You're going to see this repeated over and over again, what we're looking for and the quantity that we're looking for. And that curly brace 3 for matching 3 of the thing that it comes after is really handy, but there's a bunch of these others, and they're a huge list of punctuation marks. You don't actually have to memorize these. Very few people do memorize these. You'll just end up going back to a cheat sheet or looking them up in the documentation. But you have all these punctuation marks that mean things like, hey, I have /d, I'm looking for a digit, and the question mark, which means I'm looking for 0 or 1 of these digits, or the plus sign that means I'm looking for 1 or more of these digit characters. You can change the character class that you're looking for, too, and suddenly it's, I'm looking for 0 or 1 space, or I'm looking for 1 or more spaces. Or use your own character classes, like we did with our val example. Now we're looking for 0 or 1 vowels and 1 or more vowels. All those punctuation marks, you don't have to memorize them right now. Just remember, we have character classes at the first part. That's what we're looking for, followed by the quantity. And now for something completely different. So Japanese words are composed of letters, and Japanese letters usually follow this consonant-vowel combination. So take a Japanese word like sayonara. It's made up of 4 letters. Each of those are a consonant and vowel. It's a consonant, vowel, consonant, vowel. It's following that pattern. We can create a regular expression that will then match this. Remember, we have a character class for matching vowels, and then we also have that caret one for matching everything that's not a vowel. Technically, this will match not just consonant letters, but also numbers and punctuation marks. We'll just ignore that for right now. But anyway, say we wanted to match a Japanese word, which is made up of several of these Japanese letters. We can have the plus sign that means 1 or more of the thing that comes before it. But technically, this isn't going to work because, remember, it's just going to match only one of those consonant patterns. We need to specify how many of those that we want to match, but we also sort of want to group these together. So this regular expression is going to end up matching something like sa, but so it's a consonant character followed by a bunch of vowels. And it doesn't have to be the same vowel. It can just be any vowel that's the character class that we're looking for, 1 or more vowel characters. I'm not even going to attempt to pronounce this word. But what we want to do is sort of just group together that consonant and vowel together, and then have the plus sign mean 1 or more of these things. So we can use parentheses to group these together and form just sort of one giant character class out of all these other character classes. It's still the same thing. We're specifying what we want to look for, followed by how many of them that we want to look for. So this is going to match something like sa, 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 or it'll match an actual Japanese word like sayonara. So this would be a pretty good point for me to thematically end my talk on sayonara, but actually there's a little bit more. We're going to go into just a small example right here with regexes for a comma-formatted number. So if you're an American, you usually split up your numbers into groups of 3 with a comma in between them. So let's create a regular expression for this. We have to figure out what exactly it is that the pattern that we want to match here is. So it's generally going to be something like 1 to 3 digits for the lead part, and then followed by groups of these sort of comma and 3 digits afterwards. And we'll have 0 or more of those groups. So a number like 12 is going to have 0 of those comma groups because there's no commas. Or a number like 12,000 will have 1 of those groups. And I could just sit here and show you the regular expression for this, but there's actually a lot of nifty tools online that you can try out. These are called Regex buddy websites or Regex tester websites. And now I'm going to do something that is highly ill-advised for anybody doing a presentation, and that is a live demo in which anything can go wrong, especially one that requires using the internet. So hopefully the Wi-Fi is going to hold, and I can just use this website. So this is regexer.com. Technically, it's using JavaScript-style regular expressions, but regular expressions across multiple programming languages are so similar that it's going to work for Python as well. So let's try out, let's say I have my text. I have a 64 million year-old egg. And we want to find a regular expression that matches. Let's see how much I can move this. Not that. OK, there we go. I want to write a regular expression that matches that comma delimited number. So let's see, what was this? This was a digit, and then I want between 1 and 3 of them, so I'll try a curly brace, 1, 3. And you can see as I'm typing, in real time, these websites are going to update and show you exactly what they're matching. So these are great if you're trying to construct a regular expression and you sort of want to just build it up step by step. It's a lot easier than just running your code, seeing what it matches, then trying to go back and change it. This is a much more direct method. So let me finish this up. Let's see. We're going to have that group of the comma 3-digit thing. So I'll need another /d, and then a 3 afterwards. Oh, wait. Great, and I can see, well, oh, this isn't quite working because it's not matching everything right here, and then I'll remember, oh, right, I wanted not one of these comma groups, but 0 or more. So I'm going to add a star to mean 0 or more, and I can see, oh, OK, it matches the comma delimited number. All right, hey, I got through the entire live demo, and nothing went wrong. Woo, yes, live demo complete. Ooh. Every time I do a live demo in a talk, I feel like I'm angering the live demo god who's going to start chasing me from conference to conference, waiting for me to let my guard down and just ruin the next live demo I try. Right, not today. OK, next, pipes. This is a way that you can sort of provide alternate groups to choose from. And the example that I want to use is, let's say we want to create a regular expression to match sentences of Monty Python words. And Monty Python words, I'm going to use underscores instead of spaces just to make them more visible. And just to make it easier and more consistent, all the Monty Python words always end with an underscore. But Monty Python words will be something like egg and spam, or egg, bacon, and spam, or egg, bacon, sausage, and spam, or spam, egg, spam, spam, bacon, and spam. That one only has a little bit of spam in it. So you might think, OK, let's create a regular expression. We're going to call compile. That's the first step of compile search group. And let's see, we'll put these in a group for each word, and we'll have that plus sign to mean one or more of this. So we're going to match 1 or more egg and 1 or more bacon, except that's not going to quite work, because what if bacon comes before the egg, and what if sausage comes before egg or bacon or something like that? This isn't actually going to work as a regular expression. We just need some way of choosing one or another. And we kind of do this, if you think about it, with character classes. Character classes say, hey, we're going to match A or E or I or O or U. Except character classes only work with individual characters. We want to match groups saying egg or bacon or sausage, etc. So we can do that with the pipe character, which means or. If you've ever programmed in a language like JavaScript or something else, they also use the or character for the Boolean or operator. So it's a bit easier to remember that way. So you can just put the pipe character in between these groups to say, I want to match egg or bacon or sausage or and or spam, and then put all of those groups into one giant group, and then add a plus sign at the end so that it's matching one or more of those. And that'll match something like spam, 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 spam. Really stops sounding like a word if you say it over and over again. And the last bit that I want to cover, this is pretty much all you need for the basics of regular expressions. Character classes, quantities, groups, pipes, that's essentially it. This thing, regular expressions that you've been putting off learning for years and years and years, it's actually not that bad. The rest of this stuff is just gravy, but it's pretty cool. I really love this, the dot, which basically means match any character except for the new line. This is great because it's a great character class. You can also set a flag so that also includes the new line, but you can combine it with the star character from several slides back that means 0 or more. And when their powers combine, they form the dot star, which just means match whatever. There's a second one to this that is dot star question mark, which means match the least amount of whatever. Because dot just means match whatever character, and we're looking for 0 or more of whatever, so you can match whatever. This is great. You can use this in a string like looking for text, angle bracket, in between the angle brackets, angle bracket. This looks a lot like HTML, and so let's say we want to get a regular expression that matches this HTML-like text. That's pretty simple. We can just have angle bracket dot star question mark angle bracket. So we're just looking for whatever text in between angle brackets, the least amount of it. And then that would match a string that's sort of like angle bracket to serve humans, angle bracket. But remember, there's the one with the question mark, that's the least amount, that's the non-greedy version. And then there's just dot star, which is the greedy version. It's going to try to match the longest bit of text. And that's when you find out the dark secret that really the string was angle bracket to serve humans, angle bracket for dinner, angle bracket. Ooh, plot twist. And the reason this happens is because dot star, the greedy version, is going to match the first part to serve humans. And that technically matches the pattern that it's looking for. But dot star is going to continue looking forward to see if there's an even larger string that it can match. So if you want to match the most amount of text for this pattern, you can use dot star. And the least amount, you can use dot star question mark. That's pretty much it. You now have this solid foundation. You can go into the Python documentation and sort of look up all the rest of the neat little tricks that you can do with regular expressions. I kind of just want to end on some best practices, some limitations to regular expressions, the first of which is really important, and that is don't ever parse HTML with regular expressions. I know I went back into this slide and said, hey, that looks like HTML. Don't actually do that with regular expressions. You'll end up creating a regular expression that sort of matches HTML, and then you'll realize, oh, wait, it also needs to be case insensitive. So then you change it a little bit, and then you realize, oh, wait, there's some attribute that's out of order or something weird like that, and you'll have to change the regular expression. You'll end up making a regular expression that doesn't really match HTML. Instead, what you should do is use an HTML parsing tool like Beautiful Soup, that module. Same thing with JSON. You want to use a JSON parser to match JSON text. The second thing is, I used to use this as an interview question. Come up with a regular expression that matches a strong password, something that has lowercase and uppercase letters and numbers and special characters. The regular expression to do this turns out to be this huge, giant thing, especially because you have to get the all possible orderings of lowercase and uppercase and numbers and everything, and it's really awful. If your regular expression starts blowing up into this giant thing, that's probably a good time to just break it up into smaller regular expressions. You can just use multiple regular expressions on the same bit of text, something that looks for a lowercase letter, something that looks for an uppercase character. And then finally, this is kind of going into the computer science of regular expressions and regular languages. Matching nested parentheses. Regular expressions can't do this. Matching parentheses rely on having the same number of open and closed parentheses. They have to be in a certain order. And technically, regular expressions aren't Turing complete, which is a computer science term that I'm just going to gloss over. But you can think of it as regular expressions aren't programming languages. They don't have flow control or loops or variables or things like that. And the reason I know this is because at my last job, we were doing a code review for some web app, and the user can type in a regular expression into the text field. And we wanted to validate that, make sure they were typing in a valid regular expression. And a coworker said, hey, can you actually come up with a regular expression that matches regular expressions? And I leapt forward and said, no, you can't, because regular expression strings have groups which require nested parentheses, and that requires a stacked data structure, which means it requires a context-free grammar, and that's beyond the capabilities of regular languages. And I was so excited because it was the only time I've ever used my computer science degree for something in the real world. But yeah, so that's just some best practices with regular expressions. They do have their limitations, but they are so incredibly powerful and useful to have. So I definitely encourage all of you to keep reading about it. You can find more in the Python documentation. I also have them in the chapter in Automate the Boring Stuff with Python, which you can read for free online. But I really advise that you go ahead and whatever you do, find out more about regular expressions and use them, because yes, it is time to learn regular expressions. Thank you very much. So do we have time for questions? Yes? I guess line up at the microphones.
So we do have time for some questions. So if you have some questions, please line up here. And please keep the questions short and simple, because we have only 5 minutes left. So Yep.
Hello.
Hey.
I was wondering if you have a good use case for look-aheads.
I do. I remember, so one of the fancy things that you can do with regular expressions, wow, I've been saying regular expressions a lot today. One of the things that you can do with them is not only find, but also find and replace. So let me, let's say you had some text like Agent Alice told Agent Bob the info. So look-aheads are basically when you want to use the pattern that you found in a regular expression later on in that same regular expression. So let's say you wanted to do something where you wanted to find every case of the pattern, the word agent followed by some other name, and then using this space as telling it when to stop. And you wanted to replace it with just star, 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 but keeping that first letter. So this is sort of redacting it with a find and replace using regular expressions. This is the example that I use for using look-aheads, which I'm going to mess this up, I know. Let's see. You would basically be looking for agent and then, let's see, /w, I guess one or more of these. Oh, haha, that's why everybody's looking at me weird. There we go. Oh, now I can't see it. There we go. Yeah, we're looking for like Agent Alice, and we want to find this text and then replace it. We can use that group. That's the first group that we found, so we would replace it with this text, Agent /1, I believe, meaning just use the text of the first group. Oh, wait, no, I would want that first character. So that's in our group, followed by the rest of that name. Let me see if I got this right. And so this is called a look-ahead. It's where you use /1, /2 to refer to the groups of characters in your regular expression pattern that you've matched before. Yeah, anyway, let's move on to the next question.
So in an API that my team's writing, we use regular expressions, and we need a negative look behind. And Python only seems to support fixed width groups. So in your pattern, if you do like something and something or something or something, they all have to be the same width, which seems bizarre to us. So our solution is to just shell out to grep and do it properly in a proper proper regular expression application. So do you have any other ideas?
I mean, that is one way of doing it. There's slight variations between different languages and different command line tools in how they handle regular expressions, especially the more advanced features like these look-ahead things. Basically, if you find something that Python can't do, you could find other regular expression modules if you really, really need that behavior. There's other regular expression modules on PyPI that you can download. Do we have time for more questions, or are we out?
Hi, this question may be against the general spirit of your talk to learn regular expression. Mm-hmm. Is there a tool that lets you accept a before version and after version of a text and suggest the regular expression, or suggest some of the regular expressions you could come up with to do that?
That's kind of sort of the exact project that I wanted to work on during the sprints. Was this was going to be like a learning tool for where you can type in a regular expression and it'll just start spitting out some example strings of what it could potentially match. From the brief look that I did around the internet for a tool like this, I haven't been able to find anything that does something like that. But that's a great idea. Somebody should make that, or you can help me make that during the sprints.
We'll wait for that. Thanks.
Thanks. Do we have time for one more question?
Yeah.
Hey, Flint.
Hey, this is just intellectual vandalism. How would I handle?
So you're saying it's not a question?
Oh yeah, it is.
Okay, we have time. Go ahead. You're the last person.
How do I handle Unicode?
Oh wait, unit code? Oh, Unicode? Right. So.
No, don't answer it. Save it for later.
No, so I think I've tested this out, and Python's regular expression module does handle Unicode. I think I know this because I have this LOD.exe program I made, which copies the look of disapproval emoji to my clipboard, so I can just paste it. Oh wait, I've already erased that. But I tried pasting Unicode characters and just all sorts of weird stuff in, and it seems to work just fine. So bravo, Python.
That's good news.
Yeah. Well, I've tested that in Python 3 anyway. I'm not sure. Who knows with Python 2? But yeah, anything else? Oh, that's it? All right. Thank you very much.
So thank you, Al, for your great talk.